Recall that earlier on when we were talking about connectedness, we obtained components of a topological space as the equivalence classes of a certain equivalence relation. Well, in the context of path connectedness, we want to find path components. And they also will arise as equivalence classes of a certain equivalence relation. And that relation is that 2 points in X are equivalent if and only if there exists a path in X from one to the other. Okay. So in exercise 6.47 here, we're going to let X be a topological space. And we're going to prove that path components satisfy a couple properties that we've already seen hold for components. So part A, prove that each path component of X is path connected. This proof's a little bit easier than it was for components. Let's let C be a path component of X. And to show that that's path connected, I have to take any 2 points X and Y and C. And if they're in the same path component, that means that they're equivalent to one another, which means that there exists a path in X from X to Y. And okay, given any 2 points in C, I've found a path between them. That's exactly what it means for C to be path connected. So that takes care of part A. And for part B, prove that each path connected subset of X is a subset of some path component of X. All right, well, this proof goes just like it would for components back in exercise 6.9a. Assume that A is a path-connected subset of X, and pick any point Y in A. Okay, let's show that A is a subset of the path component of the point Y, which in this picture down here is this sort of subset here, and I've denoted it by bracket Y, the equivalence class of Y, the path component of Y. Right, why is A a subset of that? Well, take any element of A, little a, and because A is path connected, there exists some path from, between these 2 points in the set capital A. And that means that these 2 points are path equivalent, right? In other words, they're in the same path component, okay? Particular A is in the path component of Y. So I've shown that every element of capital A is contained in the path component of Y, therefore capital A itself is a subset of the path component of Y.